Today we're going to add in the derivative rules for some of our transcendental functions. So those are things like all 6 of the trig functions, e to the x, the natural log of x. We're going to look at both of those. So these first 2, we already have learned. The derivative of sine of x is going to be the cosine of x, and the derivative of cosine of x is going to be negative sine of x. The other ones are not that hard to remember, but they're not as straightforward as those. The derivative of secant of x is secant x tangent x, and the derivative of cosecant is negative cosecant x cotangent x. You're definitely going to want to put these on flashcards so that you can get these rules memorized. The derivative of tangent of x is secant squared of x, and the derivative of cotangent of x is negative cosecant squared of x. Again, where did these rules come from? They come from that limit definition of a derivative. If you use the limit definition for, say, tangent of x, you can throw a whole bunch of identities in there and work this down, and you can prove that it's going to simplify to secant squared of x every time. But since somebody else has already done that and proven it for us, we can just memorize the rule rather than having to do that the long way every time. What I want you to notice here is every single function that starts with a cosine, cosecant, cotangent are all negative. That's always how it works with our trig functions, okay? Now, the derivatives of natural log of x and e to the x, same thing. These have all been proven using the limit definition. The rule is that the derivative of the natural log of x is 1 over x. And then e to the x is a really interesting function because it turns out that the slope of the tangent line at any value on the graph of e to the x is exactly equal to the function value for any x value at e to the x. The derivative of e to the x is itself e to the x. And that's just kind of a weird thing, but that's how it works. So let's practice with some of those derivatives. Don't forget that we have to keep things in mind like constant multipliers, product rule, and different things like that. So if we look at number 7, this is just a constant multiplier 4 times the natural log of x. So that means that f prime of x is going to be 4 times 1 over x, which we could write as 4 over x. Ta-da, that's the end. F of x, this has got a constant multiplier of negative 2/3 times e to the x. So f prime of x is going to be negative 2/3 times the derivative of e to the x, which is also e to the x. Done. Number 9, hopefully you recognize this as a product rule. We have 2 different things happening. We have x squared times the natural log of x. So those are going to be our 2 different functions, f and g. Remember that our product rule is f prime g plus g prime f. So when we take this derivative, f prime of x, we're going to start by taking the derivative of x squared, that's 2x, leave the natural log alone, plus now take the derivative of the natural log of x, which is 1 over x, times x squared left alone. Now we can see that in that second term, we can do a little bit of simplifying. So we get 2x natural log of x. Whoops, I lost my x up there. And then it's just going to be plus x because this is going to divide out with one of those. And so that's our derivative. So number 10 is similar with a product rule. We're going to have to use the rule for cotangent this time. But pause the video and see if you can come up with the answers for number 10 on your own. I'll be back in 3 with the response. So again, we have to use our product rule here. So f prime of x is going to be equal to 3 times the cotangent of x left alone, plus the derivative of cotangent is negative cosecant squared of x, and then that's times the 3x left alone. So if we rewrite this, we get 3 cotangent x minus 3x cosecant squared of x. And again, you may be thinking, oh, we could pull out a 3. You can, but we don't need to. So that's a perfectly fine answer. We can stop right there. Okay. Number 11 and number 12 are important for a couple of reasons. For number 11, take a second and think to yourself, what do you think the derivative of this would be? And if you're thinking that the derivative is e to the third, you are incorrect. The derivative of e to the third is 0. Why? Because e to the third is not an unknown value. E to the third is a constant. We can plug that into our calculator. That has a numerical value, e to the third. E to the x has a derivative of e to the x. But the second I know what x is, it's not a function anymore, like a variable function. It's just a constant value. Number 12 is exactly the same thing. Tangent of pi halves is a constant. So if we think about this in terms of a constant multiplier, what we have is 5 times the tangent of pi halves times x. And so the derivative here, the derivative of a linear is always going to be a constant. It's just going to be 5 times the tangent of pi halves. And we also know that the tangent of pi halves is 1, so the derivative is just 5. Be on the lookout for those sorts of things. That's always a tricky one because we just see tangent and we automatically think secant squared. But if it's a constant, then it's not something that we need to worry about because we know what to do with constants, okay? So natural log and e are the ones that we're going to see the most often in this class. But every so often, a different base comes up. We don't want to have to worry about memorizing rules for all the other bases. So instead, we're going to use the change of base property to rewrite the log. So if I want to find the derivative of y equals the log base 3 of x, I want to convert this to natural log. So if you recall, the way that we do that is we do the natural log of what's inside the logarithm over the natural log of the base of the logarithm. And if we use our idea of a constant multiplier, that becomes 1 over the natural log of 3 times the natural log of x, which is where this rule up here comes from. This is probably the way that you saw the change of base formula used in your Algebra 2 or in your pre-calc classes. In Algebra 2, I think you worked more with log base 10, but I know in pre-calc, we focused more on natural log. And this is why, because the derivative for natural log is very easy. It's just 1 over x. Derivative formula for log base 3 of x is a lot uglier. So instead, we just want to convert it. And so y prime then would come out to be 1 over the natural log of 3 times the derivative of natural log, which is going to be 1 over x. And so I'll just stick my x in front there. That's going to be our derivative. We can use similar properties if we have a base other than e when we take the derivative. So remember that we had 2 log properties that are important to remember here. If you take the log base b of b to the x, that's just equal to x. The log base b and the b undo each other. Similarly, if you do b to the log base b of x power, the base b and the log base b undo each other. So we're using that property here to rewrite something that has a different base. So if I have a base that's other than e of, we're going to call it a. We don't want to call it 1 because 1 to any power would be 1. Doesn't matter. We can always rewrite this as e to the natural log of a times x power. Remember that when you do a power of a power, sorry, I've got a little notification coming up here. Here we go. If we do e to the natural log of a and we raise that to the x power, the rule is that you multiply the powers. So that's why they ended up multiplied here. And based on this property, this is just equal to a. So that's why these two things end up being equivalent. So we want to rewrite y equals 4 to the x as y equals e to the natural log of 4 times x power. And now to find this derivative, it actually requires something called the chain rule, which we'll see in the next unit. But the way that you would do this is your derivative y prime would end up being the natural log of 4 times e to the natural log of 4 times x power. That's exactly how that would work out. I know that's a rule you don't know yet. We're going to get there. The focus is how would you rewrite the base? That's what I want you to know there. Okay? And so that is the rules of the transcendental functions that you need to be responsible for. So start putting those on flashcards and start studying those because our test is coming up real soon.